Thank you so much, Prof. Sampath and Dr. Vijayamohanan Pillai for this opportunity. Let me also thank at this August meeting my compliments to Indian Academy of Sciences for giving a session on electrochemical energy storage and sustainability. Let me move on to the topic of my topic. I am from VSSC Thiruvananthapuram. I always start with one tributes to my guru, as Professor Sampath was telling, from Indian Institute of Science, Prof.S Sampath. He was a doyen in this area of energy storage system for a long time. Somewhere or other, we are all related to this guru. So coming to my overview, I will be talking about this. Dr. Vijayamohanan has already told about energy storage systems. And let me come to battery and supercapacitor for the energy storage purposes, what we are envisaging or employing for the space applications, and briefly about the challenges that we have come across. Then what is this supercapacitor? What are the challenges and how it is giving some solution for us in the future, especially for the India. So how we have demonstrated the technologies and what are the future scope, I will just briefly touch upon within this time. As Dr. Vijayamohanan was pointing out, we have several systems, but when it comes to mobility, even including over our heart, we are carrying the lithium-ion battery, and everybody is having the mobile, but it contains lithium-ion, which is giving life to that. But unfortunately, we will not be able to use other things like pumped storage systems, compressed air systems. Several of them are not compatible or the compact enough for us to have it on mobility basis. But when it comes to storage, in otherwise also, the megawatts and the several crippling aspects are associated with other systems. But when it comes to electricity, it is a versatile form of energy storage. So it is always that electrochemical energy storage systems, which if they can be made more and more efficient, definitely they will be playing a role in the sustainability aspect of energy storage. Coming to the types, pump storage, thermal kind of things are there. The press of a button, we will be getting the energy, especially for space. We are totally dependent on electrochemical energy storage systems for several of our vital applications. During the launch, which definitely includes crores of rupees, and sustaining any satellite in the space without battery, it becomes very, very difficult for us to operate. So these are all kind of glimpse of requirements I am giving. I am not going to explain in detail how the battery is playing in the launch vehicles as well as in spacecrafts during the eclipse time, transfer orbit time, peak energy requirement, and over about 15 to 20 years it should sustain without any flaw. So that's how the battery becomes a very important life-limiting system in our space requirements. Then our selection criteria, as usual, we always need no mass and almost no volume, but we need the very high power, very high energy. I'll repeat power as well as energy. Whatever energy is there, if it is not given in the rate with which we are requiring, we will not be able to increase the mass to add the power. So that way it becomes very important. Definitely the recharging capability is very essential. What I try to mean is that our electrochemical energy storage system, the forward and reverse reaction should be flawlessly going on for years together without loss of efficiency. So temperature becomes inevitable, it has to meet. And then while maintaining the cycle life, there are a host of other requirements like reliability, repeatable performance, group of cells should come together. And with the lithium-ion, safety goes without saying. So it has to perform the safety aspect without any issues. And on top of all, we have always a problem with respect to the hard vacuum wherein the battery systems to operate, as well as during the launch phase, lot of vibration of the order of about 27 to 28 times of our ordinary gravity aspects will be coming into picture. So it has to withstand. So mechanically it should be rugged, and the shock, acceleration, everything will play a role. So in this we have a host of systems we have developed, launched, but these are all the set of systems we have now come across. But you can see on the right side, starting from about nickel cadmium, which was employed about 30 years back, and Prof. Satyarana was there. Followed by, it has been improving and it has been improved to lithium-ion. Now we are 1/6 of the weight. But even then, when it comes to storage and sustainability for electric vehicles or mass storage, it is still inadequate that even though we have improved by 6 times, but still another 6 times we have to go. But still, there are issues with respect to power and energy aspect. So that I will touch upon. Lithium systems are not unknown to us, whether we know or don't know, but will all employ the lithium-ion system. It does involve a kind of electron. It takes from one area, that is during charge, and during discharge it will be the opposite reaction. So we have host materials, one which will be delivering the lithium ions as well as the electron during discharge. The other electrode, that is mainly the metal oxides, which will be accepting the lithium and then accepting the electron also. So that's how. So since the thermodynamics is driving the flow of electrons as well as the flow of lithium ions to get engaged between both the electrodes, we call this one sometimes as the rocking chair battery for our purposes. Then, so it is always my fondly I call this as nothing but some few set of particles, because battery is the anode material, cathode material, then the electrolyte material. It's all kind of simple. If we to look at it, it is very simple that we have a host of materials like carbon, like the LiPF6, lithium hexapyrophosphate. So I always try to call these batteries are nothing but some few set of particles, but we'll have to put them in a right perspective so that it is able to function properly for our intended applications. So these are all the elements of technology development which we have gone through. We have developed the technology for our space, and we have also given to our India, the country, some 78 the industries have prospering industries have obtained the technology, and they are in the process of converting the technology into application. So these are all the host of activities. I'm trying to say whether developing the technology alone, whether it will be sufficient or battery is adequately poised for meeting the solutions means definitely it is not yet. So how we are going to plug the points, that is what is my point. So this is set of assembly procedure, cell activation facility. So all these things in India, it has been done. But where are we? Yes, 5 Ah, 50 Ah, 100 Ah cells we have developed, qualified for space application, and with that, baseline technology for energy storage systems, like whether it is batteries or I may put it as cell to battery and supercapacitors. Now that supercapacitor, I will be saying. So what is the problem? What is it I'm trying to say here? I'll bring in how I'll be, I'm still crippled. See, supercapacitor is somewhere here. If I look at it, the power is good, very good. So we are able to touch of the order of about 4 or 5 or 6 kilowatt per kg, but somewhere here. But the problem is that the energy wise, it is very poor. So when it comes to battery lithium ion, I have energy, maybe nearly about 10 times or 20 times more. But still, when it comes to power, it is about 1/5 only. So that's what the combination of aspects. So developing the battery, but power is not there. See, what do you mean by power? See, if I'm having the battery in the like our electric vehicles are kind of equipments, we need the power to accelerate the vehicle. So at that point of time, we call it as the C rate. C means the capacity, nominal capacity. At 1 C means 100 Ah cell, 100 ampere if I am drawing, it should be able to sustain for 1 hour. But I will not be able to wait for 1 hour to completely drain it. At times, when there is a upslope, when there is an acceleration, we will have to draw of the order of about 5C, 10C, 15C. That is also equally applicable for our launch vehicles also. When we are operating the actuators, we will have to draw huge power to see that the launch vehicle is on course, on the trajectory. See, that is the case means, what is the problem? Because lithium ion has got a lot of energy, but the rate at which it can deliver is a problem. But when it comes to supercapacitor, we have got a very high rate, but the problem is that it doesn't have the energy sustain the long duration. So this is where the problem starts. So energy systems are always at the pinnacle when you compare the all other systems. See, it is having the top level it is able to meet when compared to the physics capacitor or chemistry capacitor is somewhere here with much better power. But still, when it comes to our application, let me go to the next slide. If you see, if I have to compare my systems with internal combustion engines, we have the inadequacy. The internal combustion engine is of the order of about 2000 and beyond. Watt per kilogram, I should be able to continuously sustain. So, but the battery, if you look at it, I am nearly about 1/6 or 1/10 less when compared to the energy level. But when it comes to capacity, like the power wise, it is able, the supercapacitor is able to, but energy it is not there. So this is where I wanted to, an application wise, if I look at it, there is a big gap between the energy as well as the power. So now that if I am able to combine these two, I will be able to. But how I am going to combine is my matter. So do I increase the energy further? Whether it will be holding the key for solving the problem? No, because first of anode materials were there, cathode materials are there. If I am increasing the energy, like lithium sulfur is coming up, lithium air is coming up, I will be able to touch nearly about the cost is also will be coming down. See, I can touch about even 500 or 600 whatever per liter. But the problem is that I will go to that. The energy would have increased, but still the power I have not increased. That is what is the problem I am facing. So even for our energy systems here in the actuators, or for electric vehicles, or for the mobiles, even the communication level, if I am able to increase the power, we will be able to sustain it for long duration, and fast communication will be there. So that is where. So what is an energy storage system? When we see, it should be storing the energy at a slow pace or a high pace, but when it comes to delivering, it should be able to convert the energy very fast, and it should have the peak mode. That means if when we are storing the energy all through the daytime, evening 7 to 10, we'll have to completely deliver. That means peak mode, at least 3 or 4 times it should be able to sustain. So that is where the problem comes. The battery is not in a position to deliver at higher rate. If I am drawing the power at a higher rate, the cycle life is compromised, the shorting comes, safety issues are coming, so the cost of the battery goes up, or replacement of the battery comes. Maybe if it has to serve for 5 years, means I'll have to do it in every year kind of problems. So what do we do? See, these are all the problems. See, rate of discharge, if I am increasing from C by 10 to 10C, almost more than 1/3 of the energy only is available under the area of the curve, but remaining portions are all lost as some way. When it comes to other low temperature aspects, again the energy is lost. Suppose if I am increased the voltage for some purposes, energy is lost. So these are all the crippling aspects. So how do we understand? Yes, is it inherent with the battery? It will not be able to sustain the high power, meet the high temperature requirements, or if I increase the rate at which I have to charge or discharge, the batteries will lose the life. Initially I can fit in, but the life and the cost are associated with definitely the operational conditions. When I say, all of us, all academic side, when we look at it, there is an SEI film, there is a conductor, there is a surface film, and charge transfer resistance. There are a host of reaction steps have to take place in order to see that the electron is delivered. If that is the case, definitely there is an ionic resistance. The material comes into picture. All these things make the electron transport slow. So that's how it is having the energy, but when it comes to power, it fails. But there is no application without involving the power. So what do I do? So that's what, if you see, look at that. See, technically when I look at it, or electrochemically when I look at it, the open circuit voltage is reduced by I times. If I increase the current, automatically all this host of resistances, like charge transfer resistance, electrolyte resistance, all these things will pull down the voltage. Not only pulling down the voltage, it will also generate the heat, which is the responsible factor to bring down the efficiency of the battery, cycle life of the battery, because of hot spots and separator functioning, in the dendrite growth, all these mechanisms are setting in. So this is how the battery becomes inherently, it has a limitation with respect to transferring the electrons at a faster rate. So now that, shall we go to supercapacitor? Yes. Do we have, the concept is well known, the capacitor, the concept electrochemical double layer capacitance was known, but of late only it has picked up. We have taken up that one, and we did develop a lot of advantages were there. 1000 farad technology was developed, but the problem is that I have the energy density high but power low. But supercapacitor the other way, energy density is very low but power density is high. So these are all some of the, see, it is able to sustain the voltage, but supercapacitor will not be able to sustain the voltage for long duration. I can only use peak. So that is the kind of thing. So normally people make fun of this kind of thing. Batteries are like tortoise, and the ultra capacitors are like the rabbits. So the other way also analogies are coming out. And we have developed a host of technologies. We have qualified also. There is a very good characteristics which is coming up. Pulse power, especially for pulse power, like our pyro ignitions or short duration pulses. The supercapacitors are working very well. The concepts were proved. See, if you look at it, variety of pulses, even stage separation, if you we'll have to jettison the different stages, means we'll have to operate the pyro systems. The current is actually delivered and powered by the supercapacitors. See, some of the modules we have tested, it is giving very good performance. We have carried out a lot of cycle lives of the order of about 10 power 6 and beyond. We were able to touch, if you see, for 20% reduction capacity, we are able to touch nearly 10 power 6. And we have also completed the short circuit test, safety test. It is able to sustain, even the temperature is about only 3 degrees for 120 farad, and 1000 farad also we have done. Similarly, about 3 to 5 degrees only is the temperature is going up when we are shorting it. Then yes, we have also tested in the rocket, and it is going on in the rocket for powering the rocket for about nearly the last 3 years. Supercapacitor is doing. But the problem is, like when this kind of application comes, like in other countries, people are operating even the metro trains, but every stop they will be charging it within about 2 to 3 minutes. But this cannot be. That means for short duration, our travel, this kind of supercapacitor can be employed, but without recharge, we will not be able to go. So what is the point that we will have to do is that, so this is what we combine. If you look at the battery wise, if you see, the energy density is there, but power is less. Supercapacitor, that is electrochemical capacitor, the red one, energy is less, the power is more. Why not? Why we should not combine these two to make it as a hybrid, so that the power is also high as well as the energy is high. So it is kind of easily one can understand. Supercapacitor, the number of steps to deliver the charge is very minimal, because it is only absorption of ions. There are no oxidation reduction, but for the supercapacitors. But here, when it comes to, there are no SCI films, there are no kind of barriers for the electron to come out. So here it is thermodynamics for the energy, the amount of absorption of ions that can take place is very small. But when it comes to battery, host of reactions are to take place, so it is retarded. So these two, one is kinetically hindered, another one is thermodynamically favored. If I can successfully combine these two, whether I will be able to solve the problem of power and energy while increasing the energy density as well as power density. So this is how we did. First, we externally connected these two systems and found that we could get, see, in C/10 rate, that is, if I take a 0.75 ampere hour cell or 1.5 ampere hour lithium ion cell, if I am doing it in C/2 rate, this is the blue curve which I used to get. But when I increase the power to 7.5 ampere, nearly about 10 C rate, the energy available, as I was showing, it is very small. But at the same time, if I bring in a supercapacitor in between these two to combine with the lithium ion cell, we could get 0.75 continuous discharge as well as intermittent pulses. See, I am able to, because all the applications do not involve a continuous discharge of very high rate. It is intermittent peak requirement that is to be met with by the supercapacitor. It immediately, instantaneously, it is getting recharged. See, I am able to withdraw almost about 80 to 90% of the energy available in the battery while maintaining a 7.5 ampere pulse, and the supercapacitor acts as the intermediate system to deliver the power. So it is kind of making the capacitor charged with energy and making the battery with the peak power provided by the capacitor. So this is how we started with. But the problem is that, if you look at it, we have also tested with some of the pulse applications. The one with the red one is with the supercapacitor being there, the extent of drop is very much reduced. The blue one is only with the lithium ion cell, the drop is so much. So that's how the battery plus supercapacitor combination is acting. So why this issue is coming up, if I have to drive a car, means automatically it is the DC-DC converter will be there, then battery will be there. If I have to operate battery and supercapacitor together, host of electronic equipments, then matching the voltages between these two different concepts becomes little more difficult, and a lot of the mass, like the hardware mass, the passive mass level is going up. So this is how the problem is setting in. So how do we go about combining these two was the idea. So shall I make the different capacitor materials? Will it be possible for me to increase energy density? Yes. Energy density will go up maybe very like a less significant way only by doing all these things. We can go for organic electrolytes. We can go for asymmetric electrodes, symmetric electrodes, as well as aqueous supercapacitors. But all these things are not enough to increase our like what we want now, 500 watt-hour per kilogram level. It is not going up. So this is how we did the combination of battery, anode, cathode. Here also anode and cathode supercapacitor. If I can combine these two, if I replace the cathode by the cathode of the electrochemical double layer capacitance, we are able to get a better voltage as well as self-discharge aspect. But still, one of the electrodes is not having the enough energy. This is where the problem. I am able to increase the energy, I am able to increase the power, but energy is still not yet fully utilized from the battery as well as battery side. So this again becomes a problem. So what is it we should do? That is where we were trying to increase. With this, okay, we also demonstrated our technology here, and supercapacitor being there, we'll have a lot of other improvements like low temperature, as well as in the upslope, it will be accelerating. When the downslope, when deceleration is taking place, there will be a lot of back EMF that will be coming. If supercapacitor is there, automatically we will be able to recuperate the energy to the supercapacitor because it will be high rate. Battery high rate charging and cycle life will come down. So that way there are the energy saving wise, the supercapacitor will be able to deliver fast, and also it will be able to recuperate fast. Means nearly about 15 to 20% we will be able to save the energy also utilization wise for the any application. So now the hybrid wise, when we did, we were able to get supercapacitor aspects. Now that how we have done it, I will just show you another slide. See, now what is that we have done? Now anode is there, the cathode is there. Here this side, I am having only the cathode portion. So far what has not been done, the novelty is that we have used portion of the positive electrode also along with the positive electrode of the supercapacitor. Why I am using only the positive electrode? Because negative electrode of the lithium ion and negative electrode of the supercapacitor, the voltage wise there is no matching. If you look at here, this is supercapacitor, high power is there, low energy, but battery, low power, high energy, which I was telling. But there are a host of other conceptual matching is to take place. That is, I cannot match the anode of lithium ion and anode of the supercapacitor. At the same time, there is a crux in matching the cathode as well as the cathode of the supercapacitor. So if I am able to carefully match the voltage window of the cathode of battery as well as the voltage window of the cathode of the supercapacitor, definitely without affecting the battery electrode undergoing the heating aspect as well as electron transfer, because the cathode side also we will be able to match these two active material of oxides, active material of carbon, and anode side also we have done certain modification with respect to making the graphite itself more power capability by reducing the thickness aspects. So thus by the anode of battery, anode of the capacitor, both are combined, and the cathode of battery electrode and cathode of the supercapacitor have been combined. So that's how we were able to get. So we could increase the capacity, not the capacity, the energy power wise. If you look at it, see here battery was able to give only 1, but supercapacitor was 5 to 10, but the hybrid is able to give nearly about 3 or much more than 2 we were able to get. See, without compromise and the energy density, see 20 to 150, we are able to increase it to nearly 40 level. So that's how the combination of these two, we are able to increase it to nearly 40. So with that, we are able to reduce the battery weight by half. So that gives a tremendous scope for us to improve. So in the PSLV, we are trying to use this one now. We have also qualified all of this. Some of the qualification results I will show you. There is a voltage. See, it's very difficult to see a 4 volt and up to this much capacity. We have also cycled them here. Temperature wise, you have seen all of them are doing very good. Overcharge protection also is there very much existing. And see the pulse wise also we have compared. Dip in voltage is very much close, it is very less, and up to this, if you see, it's very rare to see a 100 ampere current discharge from a 3 Ah cell. And self-discharge wise, it is in par with the lithium-ion cell for 4 days. It doesn't exceed more than 5 millivolts. This is how we were able to achieve here. The actuator profile, if you see what we used to use about 15 Ah cell, now that we are able to meet nearly about 3 Ah cell. Short circuit also, it shows that the internal resistance also is less, and 3 Ah cell is able to deliver nearly about 380 ampere. So that is the kind of internal resistance, and with that, there is no smoke or fire or any explosion. It is meeting the international standards, and safety-wise, it is very, very well maintained. And if you see the power-wise, 60 C rate for pulses of pyro ignition, it is there. More than 2 seconds, about 40 C it is able to sign. Then over nearly about 800 pulse. If you see the current-wise, the red one is able to see almost nearly about more than 2 hours and 15 minutes. We could get continuously the pulse of about 60 C or 40 C. We are getting it. So this is how we were achieving. So now that what is that we have done is that from the battery, like in management parlance, the tortoise and rabbit were fighting, and they were not able to touch the finish line. So one guy was this side and another guy has already gone. But if you combine them properly, see, in the land, the tortoise can travel over the rabbit, but in the water, rabbit can travel over the tortoise. So combining them in the right way, we will be able to see that both the guys are able to meet the finish line. So that's how the kinetics, thermodynamics, the rate capability of battery has been improved, energy capability of the supercapacitor has been improved. So with this, I'll say that the technology development involving the host of activities that are supercapacitor, battery, as well as our supercabattery, all of them we have completed. And with this, if you see, if the gap has been made as a crossmark, and supercapacitor thing we were able to touch here, and in the advanced lithium-ion technology also could come up to IC, and we will have to prove that the supercapacitor is thriving in the battery aspects. With that, we will be in a position to see that the sustainability aspect is existing. So the host of electrical aspects, which will be otherwise crippling about the operation of electric vehicles, can be brought down to a single device with these conditions. And with that, I'll say that supercapacitor is a complementary system, and it is our advanced materials which will store and deliver the power, and we will be able to definitely touch the 500 watt-hour per kilogram mark. Presently, we are getting about nearly about the 200 to 250 watt-hour per kilogram, which we will be able to sustain. And this is how we demonstrated a vehicle in Pune in one of the ARI conferences with the minister being there. And with that, let me thank all the people, because when we are eating the fruits, it is always good to remember the scientists who have planted the trees. These are all the scientists across our India who have been working in battery areas, and some of these things, scooter with our battery systems was demonstrated. Thank you so much. Thank you so much.
Thank you very much, Dr. Ilangovan, for a very nice presentation. I see a couple of comments in the chat box. Let me just read out. This is from Dr. Vijayamohanan. This is about several papers appearing on supercapacitors from India, but no manufacturing of supercaps in India. Any specific reason in your opinion?
Yeah, so actually we have transferred the technology to now our Kerala Electronics Keltron for the manufacturing of the supercapacitor, because it's an upcoming field. They are also having a market survey. Everything is required for imbibing the technology for application. So with that, we have already transferred to maybe about a year back. They are setting up the plants.
Okay.
Otherwise, import is there. A lot of imports are there. With our technology, lithium-ion as well as the supercapacitor, we have transferred the technologies. It is coming up actually, because the indigenous technology means, as you know very well, there are a lot of hesitations. Once we demonstrate only, they will be coming up.
There was also some kind of a prototyping at CMET, right, in Trichy?
Yeah, definitely. We were also involved. We were involved in the discussion aspects. They are actually good. They have made the raw material. we have used in our devices also, it's equally efficient.
It is one another comment by Dr. Anantha Krishnan. While all efforts are being made to develop efficient batteries, is there enough work being done to see how to deal with batteries that reach the end of life cycle? Recycling.
Yeah, because before implementing in our space applications, end of life, I was saying for the supercapacitor up to 10 power 6, 10 lakh cycles we have completed nearly 5 into 10 power 6. No, 5 lakh cycles we have done.
No, but I guess, Dr. Ilangovan, this is related to probably recycling. I mean, what do you do with the batteries that are used up?
Recycling?
Yes.
Yeah,
Yes,
recycling.
yes.
There are a couple of technologies are being attempted. Maybe Dr. Pillai also may be attempting, or around the country, we are about 4 or 5 groups are working about recycling the costly materials, especially the cobalt and the copper.
All right. I do not see any other comment here. I think we'll just close this session. Thank you very much, Dr. Ilangovan, for a fantastic presentation. We'll just close this and then get on to the next speaker.
Thank you. Thank you so much for the